We're going to keep looking at circles and angles, and we're going to look at a different type of angle. So for a quick review, we started with central angles, where we said if it comes from the center of the circle, it's a central angle, and a central angle is the same as the intercepted arc. So for example, if in this problem this arc was 81 degrees, my angle would be 81 degrees. They're always the same. Inscribed angles don't go through the center of the circle. They're inside the circle and they touch the edge, and their relationship is that it's half. So the inscribed angle is half the intercepted arc. So for example, if we said that the intercepted arc was 90 degrees, that means that the angle would be 45. Okay, so central angles are the same. Inscribed angles are half. The new angle we're going to look at is what we call a circumscribed angle. And a circumscribed angle is going to be on the outside of the circle, and it's going to make it to where the circle fits nicely in that angle. And part of that is that it's going to form a right angle with the radius. And we actually call this segment here tangent to the circle because it's only going to touch at one point. If you imagine a circle, you could have a segment that barely touches at that one point, and that's what we call tangent. But if it was at any other angle there, it would end up going through twice and touching it twice. There's only going to be one point at any given spot on the outside of the circle that only touches exactly at that one point, and that's what we call tangent to the circle. And being tangent to the circle makes it make a right angle with the radius. All right, so if we look over here, I'm going to go ahead and draw on the radius. So we're going to have a radius there that makes a right angle, a radius here that makes a right angle. Now if I look at this as a quadrilateral, and we'll call the circumscribed angle X and the central angle here Y, right? I know that the X plus the Y plus those two right angles has to give me 360 degrees because that's how many degrees are in a quadrilateral. So I can say X plus Y plus 90 plus 90, those are my two right angles, equals 360. And then X plus Y plus 180 equals 360. And then subtract the 180 over. So that means X plus Y equals 180. This is like a rule for all of these circumscribed angles. So the central angle and the circumscribed angle add up to 180, and we call those types of angles supplementary pairs. Alright, so X and Y will always be supplementary. So my rule for circumscribed angles is that the circumscribed and central angles are supplementary. So they will always add up to 180. So central angles are the same as the arc, inscribed angles are half of the arc, and circumscribed angles are supplementary with the central angle. So a couple of examples. We've got a 165 for my central angle, right? And I know that these are going to have to be right angles, so we can kind of ignore those. And if I call this X, we could say X plus 165 equals 180. So subtract the 165 and X equals 20. All right, for the second example, it looks a little different. It doesn't tell me that central angle. Right, but this central angle here, if I call this M, is the same as my arc here. Right, because central angles are the same as the arc. And so if I know that this major arc over here is 265, I can subtract that from 360, and that tells me that my arc over here is 95, which means that my central angle is also 95. So then I can say X plus 95 equals 180, and subtract 95, and we get X equals 85. So central and circumscribed angles are supplementary, so they add up to 180.